Okay, these are systems of equations notes, and there are two ways to graph a system, which is just two or more equations, or sorry, two ways to solve. One is by graphing and one is using algebra. And there are two types of algebraic ways, and we'll do that. But to solve by graphing, you could start at we're going to graph this purple one. Start at -4 and go, you can go up or down. You can put the negative where you want. If I put the negative on the 2, then I'd have to go off the grid. So instead, I'm going to put the negative on the 3. So I'm going to go up 2 over -3. 1, 2, 3. Up 2 over -3. Okay. And then we'll graph this one green. Start at +4. And it's up 2 over 1, which is off the graph. So we'll continue the pattern down 2 over 1. Down 2 over 1, down 2 over 1, and the place where they cross is their solution. So in this case, -3, -2. And what that means is if you plugged a -3 into this equation, it would become a true equation. So let's check that. -2, that's our y, equals -2/3 times -2/3 times -3 minus 4. And so that's -2 equals, these would cancel out, and you would get a +2 minus 4. So you'd get -2 equals -2. That made it a true solution. And then if you also plugged this into this bottom equation, -2 equals 2 times -3 plus 4, you'd get -2 equals -6 plus 4, which is -2. So what it means is that it makes both equations true, and the only place that happens is this one point. Okay. Step number 2, or version number 2, would be to graph it in standard form. And so first we have to set it to y equals. So this one becomes -y equals -3x minus 3. I basically moved this over here. And I'm going to divide everything by a -1. And so I get y equals, or you could times by -1 either way, 3x plus 3. For the other one, I'm going to get -y equals -3x minus 4. So times everything by a -1, and I get y equals 3x plus 4. And so if we would graph it, I'm going to do the green one first. I start at 4, and it says go up 3 over 1. Well, that's off the grid. So I'm going to go down 3 over -1. And you can see that that's still up 3 over 1. And then the other one starts at 3, and it has the same slope. So if you look at it very, very carefully, do they ever cross? No. So there is no solution. There is no pair of numbers that would make both equations true at the same time. When you solve by graphing, you could have one solution like we did with number 1, no solutions like number 2, or infinite solutions if you end up graphing the lines and they're the same line. Okay, and we'll talk about that in class. Let's move on to how we could solve algebraically, and there are two versions, substitution and elimination. And I didn't leave you enough room for how to do the steps, so you may want to do it on a separate piece of paper, but I'm going to cover over these problems and do it here. Okay, I have erased those two questions. You may, on a separate sheet of paper or a little sticky note, copy these down, pause your computer, and copy both of these down, and then I will use them. So I'll just give you 1 second for that. And we're going to go ahead and do substitution first. So substitution, step number 1, says solve for one variable. So looking over here at 3, I'm going to solve for this y because it's the one that's almost by itself. So I do that by adding 7x to both sides. And I have y equals 7x minus 3. Okay. Now step 2 requires me to plug this y equals in here because we're trying to find when we have the same x in the y. So we're going to put this y right here. So that's sub 2. Okay, substitute into the other equation and solve. So I have 6x plus 2 times 7x minus 3 equals negative 6. Looks like I didn't give you guys quite enough room. If I were to solve, I would get 6x plus 14x minus 6 equals negative 6. Okay, combine like terms, and that's 20x minus 6 equals negative 6. Add 6 to both sides, and I get 20x equals 0. Divide by 20, and x equals 0. So now I go to the next step. Step 3 says substitute that solution back into the equation from number 1. So we have x equals 0, and this is our equation for number 1. So y equals 7 times 0 minus 3. So in this case, y equals negative 3. So our solution is 0, negative 3. Okay, let's try that again with number 4. So back to step 1, solve for one variable. In this case, there's lots of options. So, well, not lots of. You could solve for x or y. Really, you could solve for any of them, but I'm lazy, so I'm going to solve for x. And I get x equals negative y plus 5. I just minused y from both sides. Step 2 says to plug this x in to this one. So negative 2 times negative y plus 5 minus 2y equals 2. So I literally put this right here. Now it says then to solve. So negative 2 times 2, or sorry, negative 2 times negative y is 2y minus 10 minus 2y equals 2. Oh, 2y minus 2y go away, and we have negative 10 equals 2. That's a problem. We're going to be done here because this is not true. So in this case, these two lines don't cross. There's no solution. If by some chance you had gotten something that's true, like 2 equals true, or 2 equals 2, but all the variables disappeared, that would be infinite solutions. Okay, again, where it's the same line, and so they cross at every single point. Okay, now we're going to do elimination. Step number 1 is to find and make opposites. So what I mean by that is I need two numbers that are opposite. They're the same number but different signs. And I see that right here I have a positive and a negative. So if I were to multiply this bottom equation by 8, I'd get a positive 8 right here and a negative 8 right here. So I'm making an opposite. So I have the original equation 2x plus 8y equals 14. I just rewrote this. And then I'm going to time stuff together. And I get 7 times 8. That's 56x. 8 times negative y. That's negative 8y. That was the whole point. And 8 times 20. That's 160. So that's step 1. Now if we go back up here, step 2 says add and solve. So I'm going to add these two equations together. And the whole point of making opposites is that positive 8 and negative 8 will go away. So we have 58x equals 174. If you divide both sides by 58, you get x equals 3. And then our very last step up here says substitute into either equation and solve. Okay, it doesn't matter which one you put it back into. I'm going to put it back into, I usually put it back into the one I didn't change, but it truly doesn't matter. And let's see what color this was supposed to be. Pink. Yep. So I'm going to put it back in to this original equation. 7 times 3 minus y equals 20. That is 21 minus y equals 20. Minus 21. negative y equals negative 1. So y equals 1, which means my solution is x is 3, y is 1. Again, you can use substitution or elimination. Alternately, you may have a favorite, or you might see when one is easier than the other. We have one last problem. Okay, right here. It says to find and make opposites. So I don't see any opposites, but I could make them. And again, I could time stuff, but I'm thinking if I were to divide this by 4, it would turn into a negative 4. And if I were to divide this by negative 3, it would turn into a positive 4. So that's what I'm going to do, is I'm going to times both things by a fraction. Okay, so I'm going to times this by 1/4. That basically divides everything by 1/4. So 1/4 times negative 16, that's negative 4x. 1/4 times negative 36, that's 36 divided by 4, that's negative y. And then negative 12 divided by 4, it's negative 3. Okay, and I'm going to actually change color for this one just so you can see the other equation. Okay, this is dividing by negative 3, or timesing by negative 1/3. So negative 1/3 times negative 12, that's positive 4x, that was the whole point. Negative 1/3 times negative 27, that's positive 9y. And negative 1/3 times negative 9, that's positive 3. So that was step 1, as I found and made opposites. And I was looking specifically here to make this into a negative 4x and a positive 4x, which I did. But notice I made opposites everywhere. So when I go to do step 2, which says to add, this goes to 0, this goes to 0, and this goes to 0. Well, we got something that's true. 0 equals 0. So there are infinite solutions. Okay, so that is solving in a nutshell. Solving a system in a nutshell. We will learn how to use the calculator in class to do it for you. And then I will also give you this worksheet that shows you when it's best, kind of zeroes in on everything. So finish all of the factoring stuff, and we will do system stuff in class.